4.7 triangles and coordinate proofs. Okay, so we're essentially kind of just jumping right in here, developing a proof, describe a plan for the proof. So they're going to give you some information and then what you're trying to prove, and then they're also giving us a picture, so I'm going to do my best to draw out what we're looking at. So number 4, we're given that GJ bisects angle OGH, and we're trying to prove that triangle GJO is congruent to triangle GJH. Okay, so that's what this picture looks like. Approximately. Obviously, mine's not as good as theirs, but if I use graph paper, it'd probably also look a little nicer than this one looks. Okay, so ultimately, we're trying to prove that we have these two triangles that are congruent. So basically, this one and this one, that we're trying to prove that they are congruent. So we need to first, obviously we're just writing a plan, so first we would need to use the distance formula to show that OG is congruent to GH. We know that GJ bisects angle OGH. So then what must be true of these two angles? They have to be congruent. So, given that GJ bisects angle OGH, then we know that angle OGJ has to be congruent to angle HGJ. So if I'm trying to prove these two triangles are congruent with the information after I've shown that OG is congruent to GH and that angle OGJ is congruent to angle HGJ, what else would I need to say so that I could prove that these triangles are congruent?
GJ is congruent to GJ.
Yep, then I would need to show that GJ is congruent to GJ by the reflexive property. And so then we can show that triangle GJO is congruent to triangle GJH by side angle side. So kind of like the big difference with the plan for the proof versus actually proving it with the coordinate proof is really just that I said that I would need to use the distance formula to show that those two sides are congruent. If I was actually doing the proof, I would either show using the distance formula or depending on how it's oriented, I might just be able to count what it is. This one I would have to use the distance formula on. And then the other stuff, though, pretty much is just given information. I don't really have to do anything with that. So the only real difference would have been that I had to show this here, as far as like what the proof looks like. The next one's place the figure in a coordinate plane, label the vertices, and give the coordinates of each vertex. So they're going to give you a shape, and then they're going to tell you where one of the vertices has to be, and then we're going to basically plot the other ones as well. 6, a 5-unit by 8-unit rectangle with one vertex at 0, 0. So just like the one that was in the PowerPoint, there's going to be 2 different ways that I could set this one up. Really doesn't matter. But I'm going to do it just so I don't take up as much space up and down on my paper. I'm going to do it where the 8 is going sideways. But because they only gave us the point 0, 0, it doesn't matter which way it oriented. If they had given us a different one of the points, then it would make a difference on how I orient it. So I know that I have a point at 0, 0. So I'm going to call that A. And I have to label what each of them are. So A is 0, 0. And then I'm going to use B, C, and D as well. So we'll write what those will be in just a second. And you can choose whatever letters you want. I mean, within reason, I guess, but typically we just use A, B, C, D. All right, so then I would have another one if it's 5 by 8. I would have another one if I go up 5. I would have one here. And what would that coordinate be?
0, 5.
Yep. 0, 5. I know that it's also, or it's 5 by 8, so since I did 5 that way, I'm going to do 8 this way. X first. I don't actually, well, whatever. It doesn't really matter what I call A, B, C, and D, but I'm going to actually change this to D because that way they'll be in order. So D would be what? 8, 0. C's, I haven't made my rectangle yet, despite whatever my iPad is currently drawing as an attempted rectangle there. So then my other coordinate would be what?
8, 5.
Yep, 8, 5. That'll be my C. I just like my letters to be in order. If you had done it the way I initially wrote it, where I wrote C here, totally okay also. So that's all this one's asking you to do, and then just connect them to draw your shape. So again, just so that we can see it, I could have also done this. And drawn my triangle like this and had different coordinates for that one. Okay, that would have also been fine. This is one of those answers may vary kind of problems, but I would draw it either this way or this way. Don't draw it up here and nowhere land, because then you got to do a lot more effort. All right, 8, a square with side length S and one vertex at S0. All right, so what's different about this one compared to the last one? Yeah, there's a variable. So if you still want to draw little tick marks on your graph, you can. Doesn't really matter because we don't know what those increments are, right? Because technically it could be anything because we don't have enough information to know. But we can also just draw. Is it not going to fix it? We can also just draw our graph where we're like, okay, well, this is S here, this is S here, and we can go about it that way. But if you want to draw little tick marks along the way, you can do that too. So I know that it's got side length S. I have one vertex at S0. So that means that I have 1 point over here. So I'll call that one A. So A is going to be S0. Where else do I then, if it's a square, have to have a point?
At the upper S.
What would that be?
That would be 0S.
Yep. We'll just call that one B this time, because why not? So I have another point up here. Where else? SS, yep, I'd have one there. We'll call that C. And then what about my last one? Yep. 0, 0. So I'll call that one D. And then just draw your square. So now I could have also, I just knew that I had a vertex at S0. I could have drawn my triangle, you know, or my triangle. Wow, that's not a triangle, that's a square. Could have also drawn my square over here, but we, like I said in the notes, we like to keep it over here toward the origin because it makes it a lot easier. All right, questions on those? We're getting ready to get into some where we're doing a little bit more solving. All right, 14. Using the distance formula, place the figure in a coordinate plane and bind the given information. So, 14 is a right triangle with legs of 7 and 9 units. So that just means the two sides that are not the hypotenuse. And then they want us to find the length of the hypotenuse. All right, so first thing, it says place the figure in a coordinate plane, so we need to graph it. So I'm going to set it up. All right, any preference on which way we draw our triangle?
Oh.
Up where?
Is that
7 up.
I went 9 by 9. Okay, 7 up. In case anybody's thirsty. It's like, what just happened? All right, and then what else do I need to put on here?
0, 9. No, wait, 9, 0.
9, 0. So then I'm going to draw my right triangle. Falling out of your chairs over there?
I heard something
Okay, so now here's my triangle. So this point up here is what?
B.
Oh, wait, hang on.
No, it's
0,
0,
7.
7. This one is
9, 0.
this one?
Oh,
0, 0.
I thought you were talking about the other.
Then this one, Abby.
9, 0.
We're all failing.
Hard to see where I'm pointing, I know. All right, so we want to find the hypotenuse, so I need to use my distance formula. So I'm going to do a quick refresher on our distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, it doesn't matter which point is 1 and which one is 2 as long as you're consistent for both x and y. So I'm going to call this point point 2 and this one point 1, and I'm just going to put it there for reference for which one I'm dealing with. So d equals the square root of, well, x2 is 9 minus x1 is 0. If you don't want to write the zeros, you don't have to. Squared plus, in this case, y2 is 0. So the only caution that I'm going to give you is if you put a 0, or if you don't put the 0, make sure you still put that minus sign there. And then y1 is 7, so 0 minus 7 squared. So then we've got the square root of 9 squared plus 7 squared, because that negative 7 is going to become positive. So square root of 81 plus 49, and that gives us what?
130.
Square root of 130. So that is the distance of the hypotenuse here. You don't have to write it on your triangle, but I'm just showing you for reference. That would be the distance of that part right there. Now, for the sake of time, I'm not doing another one of those, but if you had an isosceles right triangle, what would that mean about the legs of my right triangle?
They would
Yep, they would be equal to each other. So, like, if this one was isosceles, they both would have had to be the same. This one isn't, obviously. But just be aware of that as far as that goes. The other ones are just squares or rectangles, which should be easy enough. For squares and rectangles, if they're just asking you for the side length of the square or the rectangle, obviously you can just count. You don't even need to use the distance formula. But in a lot of cases, they're asking you for the diagonal of that, okay? So if they asked you for the diagonal of, let's see what shape this is, a rectangle, okay, then we would be using, if this is A, B, C, and D, then I would be using, like, I would be finding the distance of BD to find the diagonal. Or if it doesn't specify, then you could also do the distance of AC, because a rectangle, both diagonals would be the same thing. So just be aware of that if you have one of those ones in your homework, that don't think, oh, the diagonal is just going to be the same, I can just count it. It would be like finding the hypotenuse of a right triangle, because essentially two right triangles stuck together form either a square or a rectangle. Okay. Am I looking at the right page? Yeah, okay. Next problem, use the given information in the diagram to find the coordinates of H. So they're going to give us some of the coordinates, and then we're going to find the other ones. Pretty much we're using the midpoint formula to do that. So give us another graph. They count by 10, so just know as I'm putting markings on here that they're counting increments of 10. All right, and they want us to. Oh, well, not really. They tell us also that triangle FOH is congruent to triangle FJH. And we're finding the coordinates of H. Now, I'm going to tell you when they give it to you this way, you can pretty much just look at the coordinates of the graph and figure out where the midpoint is because they've already put it on the graph, right? So I can count over and be like 10, 20, 30, 40, 10, 20, 30, 40. The midpoint's at 40, 40. But for a refresher, I want us to look at the midpoint formula just so that we can see it because they aren't all necessarily going to be
Is that O or D?
where? Right here?
Yeah.
Oh. So midpoint formula is x1 plus x2 over 2 and then y1 plus y2 over 2 and it produces a coordinate ordered pair. So in this one, because we're adding, it really doesn't matter which point is point 1 and which one is point 2, but I'm going to do this one as 1, this one is 2 here. So for our case, we have the midpoint is going to be 0 plus 80 over 2. And then same thing for the other one, 0 plus 80 over 2. So that just gives us a midpoint of 40, 40. So like I said, we could see that from the graph, but just so that we're familiar with the formula and have refreshed on that, it's there for you. But in pretty much all of the ones they give you, you could literally just look at the graph and write it down. So, questions on that so far? Getting ready to get into 2 proofs and then we'll be done. All right, the first one is just a plan for the proof, but as we already talked about in one of them, like obviously it looks a lot like the actual proof, and then the other one will be doing a coordinate proof, which pretty much just means we're actually using the distance formula instead of just stating the information of what we would be trying to do.
Are they long proofs?
Not really. Okay, so 20, we're given that OS is perpendicular to RT, and we're trying to prove that OS bisects angle TOR. And then, of course, they're going to give us a picture. I'm going to write my picture over here so I can do my proof beside it. They're counting increments of 10 again on this one. Yes.
Why do we have 2 R's?
Cookie point.
No.
Oh.
I tried.
All right, so again, this one is just writing a plan for the proof. So the first thing that we would need to show is that OR is congruent to OT, right? Because I'm trying to show that this bisects, so I'm going to need that information. So use the distance formula to show OR is congruent to OT. Then, assuming that that is true, which I can already tell is going to be true because the way this is lined up, I can just count, but these two sides are congruent, then I can use the base angles theorem to show that angle R is congruent to angle T. And then because I know that angle OSR is 90 degrees, that also means that this angle over here is, so I can show that these two angles are congruent by the right angles congruence theorem. So use the right angles congruence theorem to show angle OSR is congruent to angle OST. And then at that point I have an angle, and or angle, and a side here, the side over here. Now, in theory, obviously, that is as well. But with what we're trying to show, I'm going to use angle, and this side over here to show that the triangles are congruent. So use angle, side to show triangle OSR is congruent to triangle OST. And then if that's true, what would allow me to show that this angle is congruent to this angle?
CPCTC.
Yep. And finally, use CPCTC to show angle ROS is congruent to angle TOS, meaning OS bisects angle TOR. Now, that one's longer than the one that you actually have to prove, so. Plan is longer.
So is planning and proof pretty much the same thing as a coordinate proof?
They're pretty much the same. The main difference with the coordinate proof is that you're going to actually be giving the values. We are pretty much just saying this is what we would be using, but it looks a lot like a paragraph proof when you plan a proof out. So yeah.
Wait, so coordinate proofs and paragraph proofs are the same?
Sort of. They look the same, kind of, and because you're like essentially writing them like sentences. But with the coordinate proof, you're like using the distance formula, midpoint formula to like evaluate things like mathematically and then show that they're equal or like congruent depending on what you're looking for.
So you're using things that would apply to the coordinate plane?
Yeah. They're gonna have a graph with them, basically. Okay, so then our actual proof here, 26, write a coordinate proof. Given is that the coordinates of triangle NPO and triangle NMO, which that's what you're given in the graph that they give you, so I'll write what those are in just a minute. And we're trying to prove that the triangles are congruent. So triangle NPO is congruent to triangle NMO. So they give us the point 0, 0 is O. And then M is over here, and it is 2H and then 0. P is 0 and 2H. And then N is HH. And then it's connected to O that way. Okay, so with the previous problem, we said that we would need to use the distance formula to show that OR was congruent to OT. But technically, like I said with that one, because of the way that they set it up, you don't even really need the distance formula because it starts at 0 and then it goes to a value, so we can just see what those two values are. We'll be able to do that same thing with this one. So to set up my coordinate proof, I would start out saying OP is equal to 2H, because I can see that it goes from 0 up to 2H, and OM is equal to 2H as well. So with that information, I can say OP is congruent to OM. Then I could technically find the midpoint of this to of PM to confirm that N is the midpoint, but I can also just see if this is 2H and that's at H, that I can just see that that has to be the midpoint. So I'm just going to use the information that they've given me in the graph and say by the midpoint formula, N is the midpoint of PM. So that would then mean that PN is congruent to MN. What else do I know has to be true about this?
OM is equal to ON.
By
Reflexive property.
Yep.
The only thing I know.
I've used that a lot. So by the reflexive property, ON is congruent to ON. So now I've proven that this side is congruent to this side, this is congruent to this, and then this overlapping side, I usually just put little marks there, but that also is congruent. And so now I can say triangle NPO is congruent to triangle NMO by side, side, side. So hopefully these ones are a little bit easier, other than just that they're different in how you write them. Any questions on this?
That's it.
I wouldn't stress too much over this section, other than just make sure that you know how to write a plan and then actually do it. But like I said, they're very, very similar in what you do. You're just in the plan, you're not actually finding the distances or the midpoints. You would just say that you're using those formulas to show this particular thing. Yep. All right, problems 7, 15, 17, 19, 21, and 27. So yes, these are due Friday. However, you have a quiz on Friday on 4.5 to 4.7. So if you have time tonight, I would suggest you start working on these, especially 21 and 27 that are planning a proof, because I can pretty much tell you you're going to have to either write a plan or actually do the coordinate proof on your quiz on Friday. So I would say if you have time to do nothing else, if you can do these, great, but it is Wednesday. Your quiz review is at the end of this section. It's only 3 questions, so you'll have that to do tomorrow in class. So you should have time to work on this and that tomorrow. But make sure that you are working so that you can ask questions tomorrow and all of that. Yes.
Are we allowed to do the quiz review tonight with, along with the homework and get it checked tomorrow?
Yep, that's fine. Huh? Well, let me see what Harrison's asking, cause he had his hand up. Okay,
Okay, go ahead.
because there's like 2 minutes left, I'm gonna let y'all go ahead and go.